Alright guys, 73. Your answer is 1.8 meters. A child slides down a frictionless 3-meter long playground slide, tilted up at an angle of 40 degrees. So I have this going on. This is 40 degrees. I know this much is 3 meters. At the end of the slide, there's an additional section that curves so that we're launched horizontally. So ultimately, this little kid is going to be taking that kind of path. At the end of the slide, there's an additional section. Okay, how fast is the child moving at the bottom of the slide? So really, we just need to take this 3-meter chunk. We know VI, or we have to assume VI is 0 meters per second. We're going to find VF here. And then, yes, this is curving, but it's really not important. The understanding of this question is just, here we have a velocity and it curves just enough so that way we're going to keep that velocity and actually launch horizontally like that. So first of all, we have to find our acceleration. Now remember, acceleration is a vector. So here my acceleration vector is negative 9.8 meters per second per second. That makes this angle right here 50 degrees. And I'm looking for the acceleration down the ramp. So I'm looking for this vector here. Now you can see that I have a nice little right triangle. I'm looking for my adjacent side to 50 degrees, and negative 9.8 is my hypotenuse. Now this is going down the ramp, but if we're looking at this as a linear problem, I want this acceleration positive. So I'm just going to ignore this negative right here. So we're going to say my acceleration down the ramp equals my hypotenuse 9.8 times the, it looks like the cosine of 50 degrees. Okay, now if this is 40, this 50 degrees just comes from geometry, okay? You could have said that this was 40 degrees, and then you would be looking for the sine of theta. So 9.8 times the cosine 50 degrees. If I can get my calculator situated. 6.3 meters per second. Now if I have my acceleration, I know my initial velocity is 0, and I know the distance down the ramp, I can just use the equation without time in it to find VF. So VF squared equals 0 squared plus 2a, we just found to be 6.3, and delta x, which is 3. So if I take the square root of this, I will have VF. So VF equals the square root 2 times 6.3 times 3. Oh my gosh. 6.14 meters per second. So that's A. So I guess this 1.8, sorry, was the answer for B. So part B says, if the end of the slide is 0.4 meters above the ground, so it tells us this is 0.4 meters, that means delta y is negative 0.4 meters. How far, so it's asking for delta x, how far does she end? Now obviously this is an exaggerated picture here, but let's go ahead and do that. I want to do what I've always done. I'm going to use this delta y to find time. And I know my Vx is going to be this velocity that I leave the slide with, and I'm going to solve for delta x. So we're good. Negative 0.4 equals VIY times t, so 0 plus 1/2 negative 9.8 t squared. This is nice, no quadratic needed. So negative 0.4 times 2 divided by negative 9.8. If I take the square root of that, I will get a time of 0.29 seconds. Now I know delta x equals vxt, so delta x equals 6.14 meters per second times 0.29 seconds, so delta x equals 1.8 meters. Yay, we got it right. Alright, let me know if you have any questions.